graph and see what happened to this function right here. So it says let f of x equals 3x plus 2, and they want us to graph t of x is equal to f of negative x. So in that case, we're going to go ahead and see which transformation that is. So looking at my chart, I can tell that it's a reflection because of that negative, and it's actually going to be a reflection across the y-axis. So I'm going to write reflection across the y-axis. Okay, we're actually going to prove that in a little bit. So we're going to go ahead and graph the original equation. I'm just going to do that really quickly. F of x equals 3x plus 2, so y-intercept is at 2, and I'm going to go up 3 to the right 1. Or down 3, left 1. Okay, then we're going to connect the lines. Sorry guys, I am using my laptop to graph that, so I can fix this right here. All right, that works. Okay, so here's my arrowhead. All right, so that is f of x equals 3x plus 2. I'm just labeling that. Now we're going to reflect across the y-axis. So that means that I'm going to take each point and reflect it on the other side of the y-axis. Now remember, this is the x-axis, this is the y-axis. So I'm going to go ahead and grab the red color. And for every point, I'm just going to reflect it across the y-axis. So I'm going to start on this one here, and I'm going to move over to the left one to get to the y-axis. So that's going to be same distance away. This point right here stays on it because it's on the y-axis, so it stays there. This one is going to go to the right 1 step. It's going to go to the right 2 steps from the y-axis, and 3. Okay, so when I graph this, I am going to have a line that was reflected across the y-axis. And this function would be t of x equals f of negative x. I want to solve it algebraically to come up with the equation and make sure that that equation matches what we just did manually, like hand did. We physically did that. All right, so I'm going to take t of x equals f of negative x. And in order for me to do that, I know that f of x is the same thing as 3x plus 2. So I'm just going to write that. But we want to do t of x is equal to a negative x, right? So we're going to substitute that negative in to x as negative x plus 2. So we're going to get t of x equals negative 3x plus 2. So let's check to see if that's correct. Let's see if that equation matches our graph. So at 2, yep, our y-intercept is at 2, and I'm going to go down 3 to the left 1. Down 3, left 1, yes, it's on the graph. So yes, this is t of x, and t of x, the equation can be negative 3x plus 2. It means the same thing.